So how could this be more complex? Well, there could be an extra downward force. So in this problem, the block is being pulled to the right, but something else is also pushing down on it. You can imagine that to be anything you want. Maybe it's wind, maybe it's a person, however you want to think about it. Maybe there's a magnet or something like that. But what we're saying is that there's some extra force down, and I haven't really been told what type of force it is, so I'll just call it F. That's acting on this object. But it's still got to be true that because the object moves to the right, the forces in the y direction have to balance out. And so my picture can't be really accurate here. If I have mg and F both pushing down, this normal force is going to have to respond and be bigger. Okay, so my normal force is not a set amount for every situation or every block. The normal force responds to all the other forces that are acting on it. And so in this case, my normal force minus mg minus this extra force that's being applied has to equal 0. Or my normal force is going to be mg plus F. My extra 20 newtons pushing down. And then I can go ahead and do my same setup here. Okay, so it's not really changing how I think in the x direction. It's still the applied force minus friction. My applied force is 14 again. I'm still going to use 0.2 as my coefficient of friction. The difference, though, is that my normal force is not just the weight. My normal force is my weight, so that's the 40, plus this extra applied force of 20. And so my normal force is 60. So that's the difference here. My mass, 4 kilograms, times my acceleration. So 14 minus, now this ends up being 12. So 14 minus 12 is 2. 2 divided by 4 is 0.5. So that extra downward push changed the acceleration from 1.5 to 0.5 meters per second squared because the frictional force was bigger, because the normal force was bigger. The normal force is a measure of how much interaction there is between the two objects.